Hey Graham here, doing 511 Algebra 2 stuff, graphing our quadratic functions. So I know you've been having fun factoring and solving and doing all kinds of wonderful things with all these x squared things, but you were just wondering, man, what do the graphs look like? When are we going to get back to some graphing? Well, today's your lucky day. Alright, so here's our general form: y equals x minus h squared with our plus k. Vertex is going to be at h comma k. Don't worry about it too much right now. You should kind of remember this because this was our exact same thing with the absolute values that we did oh so many days ago, except bam, it looked like that. Didn't have the square, and our parentheses was the absolute value. What you might remember though is that this number out here was moving us up and down. This number here was moving us left and right. If you have any remembrance of that at all, it's definitely going to help you out today because it's all basically exactly the same. Does basically exactly even make sense? I don't know. But yeah, we know what's going on with those things. Alright, so here. Always can graph just by plugging in some numbers. So I've got negative 3 through 3 here. We're going to plug them in and square them. So all we're doing is, what's f of negative 3 going to be? Well, that's negative 3 squared equals 9. So you're just going to take the number and square it. I'm going to throw all those in here real quick. Couple things you should notice about our numbers. First, kind of just symmetric here. 9, 4, 1, 0, 1, 4, 9. So we just kind of start dropping down and then going back up. I'm going to go ahead and plot all these out here. Negative 3 comma 9. Hopefully remember that our x number is our left and right number and our y number is our up and down number. So negative 3 comma 9. I'm going to go back 1, 2, 3 all the way up to 9 and drop my point in here. I'm going to quickly drop in the rest of these points. Now once we do that, bam, we start to get an idea of what our graph is going to look like. And this is what's called a parabola. Kind of swoops on down, hits 0, 0, and changes direction and goes up on forever. That is kind of ugly, but that's the basic idea of what things are going to look like. So what we're going to do now for the rest of these is kind of just see how we're going to take this basic graph and slide it around. We're going to slide it left and right, we're going to slide it up and down. We're even going to take a look at what it looks like when we flip it over. So example number 2 here, we're going to take x squared minus 3. So it'd be like f of negative 3 would be, equal to negative 3 squared minus 3. 9 minus 3 gives me 6. So I'm going to put a 6 in here for that spot. Quickly, you can hit pause if you want to and go ahead and fill the rest of these in. That's what I'm going to do. So there we go. All of our numbers plugged in. 6, 1, negative 2, negative 3, negative 2, 1, and 6. Again, we're symmetrical, but some numbers have changed. It's all kind of gone down, dropped by 3. So let's go ahead and plot those out. And there we go. Got my numbers all plotted in here. Got my parabola going. I drew a nicer one this time just so you can see what's going on there. But, yeah, what did we notice happened here? Well, our vertex went from being here down to here. So what did that 3 do? That 3 dropped things down 3. So what do we think is going to happen if we have a plus 4 there? Well, instead of going down by 3, it's probably going to go up. By how much? By 4. So that number on the outside just going to tell us up and down where it is that we need to be going. Here we got that negative 1. Let's fill in our chart here. And bam, there's all my numbers. Again, we're seeing symmetricalness here. 9, 4, 1, 0, 1, 4, 9. So let's throw our points out here and see what's going to happen. You would think if I was just taking my time to draw this, I would draw a better arrow, but no, that's what I got. I got that arrow right there. So, what happened here? Well, my normal graph moved from being at 0, 0 to 1, 0. So what did that 1 here do? It moved it to the right. So we might remember that, back in the day, the thing on the inside here when we were doing our absolute value was always kind of opposite. It was moving things left and right, but it always moved opposite. So our negative here is actually moving it that direction to our positive. Well, if it's a positive 5, which way is that going to go? That's going to go left. It's going to move that direction. Alright, good things happening. Last, talking about our end behavior. This is really talking about whether we're going up forever and ever, or in this case we're going down forever and ever. So we check our leading coefficient. That's really just the number out in the front. So we're going to have our parentheses thing there. We're just looking for that number out here. We got the x, plus 2 or whatever squared. So we're checking this number here. If it's positive, we're going up. Up and up forever. If it's negative, it's going down. And in this case, they're both going the same direction. But the one that we're always checking when we check on our end behavior for right now is really just looking at the right side. Where is it going as things get bigger and bigger and bigger? So that's these two arrows that I kind of colored in. And so that's the end behavior we're really looking for. And for right now, they're both going the same way because things are x squared. In a couple weeks, when we start graphing crazier things, we're going to find out that x cubes are going to start doing some different stuff. And the right and the left are going to go different ways. But that's all for another day. So here, let's just start thinking about where things are going. I look in my front, and it's positive. That means my end behavior is going up, and my graph is going to look like it's going up. I don't have any number in parentheses, so I'm not moving left or right, but my number out here, all by itself, means I'm going to move up 2 spaces. So instead of moving at 0, 0, I'm going to move up 2, and my vertex is going to be at 0, 2. I know this is going upwards, so that means all we're going to do for our graph, and this is all that you need to do, is just decide, hey, it's going up. I'm going to draw me a nice little curvy thing going upwards. And we for sure are going to put some awesome arrows on there because it's going up forever and ever and ever. Here, let's go step by step. Negative up front means end behavior. We're going downwards, so we're going to be a downward looking graph instead of a bowl kind of U shape. Plus 3 on the inside. That's moving left and right, but we got to remember my positive kind of moves opposite, and it's going to go to the left. So instead of being at 0, 0, I'm going to move 1, 2, 3 to the left, drop my point there. That's at negative 3, 0 for my vertex, and things are going downward. So we're going to draw our graph looking something like this. Oh, that's disgusting. That might be the worst arrow I've ever tried to draw. I know I've said that before, but this one actually is. Alright, so there we are at example 6. This thing's got 3 different things going on here. So my negative in front means we're looking downward. Negative inside is left and right, and it's always opposite, so I'm going to move to the right. Positive on the outside means we're moving up. So I'm going to take my vertex and I'm going to move it 2 to the right, 3 to the up, and it's going to go upwards. So let's just do it. 1, 2, 1, 2, 3. So I move my 2 to the right, my 3 up. Oh, it's going to go downwards. Why did I even say that? That's ridiculous. It's going to go down because this is negative out here in front. Oh, there. That's the nice thing about a computer. I screw up, I could just move it. You mess up, and you have to redraw everything. So where did our vertex go? It went over 2, up 3. So that's going to be 2, 3. So here's my basic rule of kind of what I like to think about when I draw these. Y equals. Well, if we got something in front, positive means it's going to look like this. Negative means it's going to look like this. And then we've got our parentheses happening, right? Well, here, positive means it's going to go opposite and go left. A negative here means it's going to go to the right. And then our stuff on the outside, a positive means we're going to go up, and a negative means we're going to go down. So I would definitely write this down. This is kind of your general form. You look in front. Are we going up or are we going down with our curve? Inside, left and right, going on the opposites. Outside, plus and minus means up and down. So this will tell us where we need to move our graph every single time. Once you're done writing that down, go ahead and take a look at number 7. Example number 7, see if you can get that one on your own. I'm going to hit pause and take care of that. Alright, so here we are at example 8. This time all we're doing is we're looking at domain and range. Now remember, domain is our input, and that's talking about our x values. Range is our output, talking about our y's. And one kind of trick when we're thinking about this and what our graph is doing here, domain is always kind of left comma right when we're putting our set notation together. With our range, it's always the down minus the up, comma up. So how far down did it go and how far up? The low, comma the high. So domain. If this thing goes on forever and ever, how far am I going to the left? Well, if it just keeps going, it's not moving to the left very fast, but it'll get there. So that means we're going negative infinity. And how far to the right? Well, it keeps going that way forever and ever, just not very fast. So that's going to be positive infinity. Both of those are getting parentheses because you never actually get to infinity, so you can't include it, you don't get a bracket. And for right now, our domain is always going to be this, because our x squared graphs are just always going to be negative infinity to infinity. They are functions, which means we can plug in anything and get our answers back. So our range is our down and our up. Well, how far down does this graph go? Does it go down forever? No. This is as low as it go. So it goes right through that point, and it just happens to be 0. So I'm going to put my bracket there because it actually touches 0 right here. It's as far down as it goes. It drops down, 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 hits 0, and turns back around. So the low, our down, is 0. How far up does it go? Well, it keeps going up in both directions forever. So that's going to be our positive infinity here. So that's how we're doing our domain and our range. Domain, always negative infinity to infinity. Range, you got to check, where does it stop and turn around? Is it stopping and turning around on the way down, or is it stopping and turning around on the way up? This one's very, very similar to what we just did. Domain, that should be easy. Range, thinking about how low does it go. And go ahead and hit pause and see if you can write that one in yourself. Last one I'm going to take care of for you here. Example number 10. This time it's going downward. It's a negative parabola. That's fine. Domain, left and right, still going on forever and ever in both directions. So we're going with our negative infinity to infinity. Still getting parentheses on there. Now my range. How far down does it go? Well, it goes down forever. So my negative infinity there on my down part, but up, how far up does it go? It keeps going and going and going and going and going, but eventually it stops here and turns around. So what's the maximum that it ever gets to? Well, it gets there to 1. So I'm going to put 1 there, and I'm going to put a bracket because it actually touches at 1. It got really crooked there. It's kind of sad. It's like, oh well. So we got negative infinity to 1, and that's our maximum, our highest point that it ever gets to. So example number 11 here, you can take care of yourself. Remember, domain's still going to be the same. Range, what's the highest point that it gets to? Thank you for caring enough to try and listen to the video today. I'm proud of you guys. Make good choices in your lives, and we'll see you again sometime.